Hi everyone, this is the second video for section 2 of unit 2. This video is on the 5-number summary and box plots. So let's go ahead and jump into it here. So one thing that we know when we're describing distributions is that you can't get a clear picture of what the whole story is, the whole truth is, using only the center, right? Especially if you're using mean and your distribution is skewed, right? The center may not be an accurate uh, depiction of, of what's actually going on in your data set. So we use the 5-number summary and box plots and inner quartile range and all of those fun things to talk about the spread of the distribution, and as well as talking about outliers and if we have any outliers. Okay, so the first thing that you have to understand about doing this 5-number summary, right, is that you have to know what a quartile is. Okay, so a quartile is exactly what it sounds like, that it divides observations, right? Or you could think of it as just your data, right? Your data set divides observations in your data set into quarters. Okay. So if you think about your entire data set, right? Say you have, all of your data fits in this box right here. The median is literally that middle point where you have 50% on the left, right? Half of the data is below that, and half of the data is above it, right? The quartiles divide the lower half and the upper half in half, right? So quartile 1, which we normally notate with Q1, is the middle or the median of the lower half, right? So you have like 25% in the lowest quarter, 25% in the next highest quarter, then you get to the median. The upper half you can also divide in half, right? So quartile 3, right, is your divider for the upper half. It's the median of the top 50% of your data, right? So you're literally dividing your data into quarters, okay? So another way you can think about this is at quartile 1, 25% of your data is below quartile 1, okay? Your median, 50% of your data is below quartile or below the median, which technically is like quartile 2, okay? And then quartile 3 is at like your 75%, right? 75% of the data is below quartile 3, okay? So one thing I want to note for you quickly is, if you remember from the last video when we were calculating median, that if you have an odd number of observations, then you just have one data point that is the median. If you have an even number of observations, then you have to average the two middlemost points to figure out where the true middle is. So when we are dividing our data to figure out where the quartiles are, okay, if you have an odd number of observations, you don't include the median when you're calculating the quartiles, like when you're counting them, because then the median would get counted twice, right? Once when you're figuring out what the lower quartile is, and once when you're figuring out what the upper quartile is. So we just don't include the median, okay, in those cases. But if the data set has an even number of observations, then you do include the median when you're calculating Q1 and Q3, because and what I mean by the median is the two median, like the two middlemost values that you average together. Okay, so with all this talk about quartiles, right, now I can actually tell you what the interquartile range is, or the IQR is how we normally will talk about it. So the IQR is the range of the middle, if I could spell, that would be great, of the middle 50% of the data, okay? And IQR is a measure of spread, okay? So if you're looking at our division of our data up here in green on the right hand side here, so the IQR is the middle 50%. Okay, so it's the data that's between the quartiles, Q3 and Q1. So you calculate IQR. The formula for IQR is you just subtract your quartiles. Quartile 3 minus quartile 1. Okay, and so it's a measure of spread. It is a type of range. It's just a more specific type of range, right? Because normally most of your data is clustered towards the middle of the distribution, and then it kind of peters off on the edges. So IQR is usually a better description of spread if you have the ability to calculate it. Okay, so sometimes you will be asked to interpret the IQR in the context of the problem. So remember, when you're interpreting something in statistics, most of the time you are just taking the definition of that thing and then adding context to it, right? So the interpretation of the IQR is the range of the middle half of the data is uh, or the range of the middle half of the data of insert context here, right? So whatever your data is actually of, right, is blank, right? And then you would just insert the number for the IQR, okay? So we literally just took the definition, right, and added some context to it, okay? If possible, try to include units whenever you can, okay? So that's your quartiles and your IQR. So now we get to something called the 5-number summary, okay? And it's exactly what it sounds like. Okay, so if you go back up to our depiction of our data up here in green, we have these two vertical bars that we haven't put a number next to yet or a label next to, right? This lowest bar is where your minimum is, and this upper bar, which is where like you have 100% of your data is below that point, that's your maximum value. Okay, so these 5 things that you see right here, oh, terrible. Let's try that again. Over here struggling with my drawing. Okay, but these 5 things right here are your 5-number summary. Okay, so your 5-number summary of your data set is the minimum, quartile 1, the median, quartile 3, which is abbreviated as Q3. Oh, and I probably should write that up here for quartile 1. That's abbreviated Q1, and your maximum. Okay, so this is like a quick, it literally is, it's a summary, like it's exactly what it sounds like. So rather than looking at every individual data point and maybe being able to talk about the shape, if you have the 5-number summary, you can talk about a lot of different things like outliers, spread, because you'll have range and IQR, and you can also talk about median, okay? If you have a data set that is skewed, this 5-number summary is a more accurate depiction of what's actually going on with the data, because these values, the minimum, the median, the quartiles, the maximum, are not influenced by outliers. Okay, so if you have a skewed data set, all right, which I probably should write here for you. So if your data set is skewed, use median and IQR instead of mean and median, or mean and standard deviation. Okay, and again, the reason for that is because mean and standard deviation are easily influenced by outliers. Okay, so median and IQR are a better representation of the truth. I could spell, that would be so awesome. Awesome, awesome. Okay, I'm like over here struggling with a lisp while I'm doing this. Y'all, this struggle is so real. Okay, so median and IQR are a better representation of the true nature of the data. Okay. All right, so with that, let's talk about box plots a little bit. Okay, and we're also going to talk about outliers. Okay, so a box plot is sometimes called a box and whisker plot, right? That's probably what you've heard it called up to this point. Okay, but a box plot is a visual representation of the 5-number summary. Okay, so a box plot literally displays the 5-number summary. Okay, all it includes is the minimum, the quartiles, the median, the maximum, and that's it. It doesn't show any individual data points. It doesn't really show shape very well. Yeah, okay. So box plot just displays the 5-number summary data. The best way to draw a box plot is to draw the actual box first. So draw a box from Q1 to Q3, then draw a line inside the box wherever the median is, and then draw the whiskers, right, after that, which are just lines that go out to the left and to the right. Okay, draw them out to the smallest and the largest observations that are not outliers. And then when you do box plots, you want to mark outliers with either a dot or an asterisk. So you can kind of see an example of what that looks like. I have one drawn because I'm going to do this example for you in just a moment. But you can see like this distribution has an outlier in it that I marked with a little star. Okay. So all of this, and you're probably going, okay, great. We've been talking about outliers for a while, and I still don't know how to figure out when something is an outlier. Okay, so here's how you figure that out. And I'm going to write a little bit on the left side of your screen here. Okay, so outliers are determined using the IQR. Okay, so essentially what you're doing when you're using this lower and upper outlier formula is you're trying to figure out where is your cutoff. Okay, so that's the question that you're asking yourself when you're doing this. Like, where's the cutoff? Or where's the, let's say, the cutoff for extreme values? Okay, it's essentially what you're asking yourself when you're doing these calculations. Okay, so what statisticians have kind of like worked on and discovered is that, or agreed upon, really, in the statistics community, is that you can figure out the cutoff for your extreme values by taking your IQR, which again is the middle 50% of your data. That's where most of your data is. I take the IQR, multiply it by 1.5 to give yourself enough room. Okay. And then and then add that value to the upper quartile to get your upper cutoff value, right? And then subtract that number from your lower quartile to figure out your low cutoff value, okay? Here's why we do it that way. The IQR is a pretty good representation of the range of a majority of your data, okay? So if you have a very small IQR, then if you have a value, like a data point that's farther away from most of your data, right? and if you have a small IQR, then you don't have to go very far beyond the IQR in order to get to a point where you're saying, yeah, this data point is definitely too far out. It doesn't fit with the pattern of the rest of the data. Okay. But if you have a very large IQR, right, there may be data points that seem like outliers because they're very large, like they're really large numbers, or they're really small numbers, like they seem very extreme, but they may not be as extreme as you think they are, right? They may actually be closer to the trend of the rest of the data than you think because the IQR is so big, okay? So here's how we actually calculate whether or not something is an outlier. Okay, so what you do for lower outlier, what you do is you take Q1, okay, and subtract 1.5 times whatever the IQR is, okay? So that equals your lower cutoff point, okay? So any data point below that is an outlier, okay? And then for your upper outliers formula, you start at the upper quartile, Q3. So Q3, and then rather than subtracting, you're going to add because you're trying to figure out your upper outlier, right? So you want to go and give yourself space going to the right. So you add 1.5 times the IQR, and that gives you your upper cutoff point. Okay, so any data point above that value is an outlier. Okay, so this is a lot easier to kind of see and understand when you can actually see it worked out. So, and here you can see on the left side of your screen, we've talked about box plots, but this picture on here is actually a pretty good depiction of a box plot. And it shows you how you can use the 5-number summary to figure out range, IQR, median, things like that, right? So remember, IQR is your box, right? It's first quartile to third quartile. Your range would be from your minimum to your maximum, okay? And then your median is there in the middle, okay? So, okay, so we have this same data set from before of these 20, the commute time of these 20 random workers. And what I'm going to do actually is, just like last time, I'm going to move this over so that you can see the notes page a little bit clearer. Maybe not, if my computer's going to cooperate with me. There we go. Okay, so I'm going to zoom in just a little bit here so we can see this a little bit better. Okay, so this question says find the 5-number summary and IQR for this data set, draw the box plot, and then we need to determine if there are any outliers. So in order to draw a box plot, you have to figure out where there might be outliers, right? Because the outliers are represented visually on the box plot. Okay, so I already have this data organized and written in order from minimum to maximum, right? And I already know where the median of my data is because we found that in a previous video, right? Okay, so now what I have to do is figure out, okay, I have my median. Really, I should have called this median. Okay, I have my median and I know where my min and my max are, but I have to figure out where my quartiles are. So this is an even number. So what that means is that I'm drawing a line where the median is. So to find Q1, I need the middle of the bottom half, and I'm going to include this 20 right here, this third 20, right? So again, you can either do this by just doing a little bit of mental math and saying, okay, there's 20 workers total. then that means 10 of them have to be below the median. So that means in between my fifth and sixth numbers, that's where my Q1 would be. Or you can do the cross off method and literally go, okay, I'm going to cross off 1, 2, 3 on this side, 1, 2, 3 on this side, 1, 1, and so I end up here, right? So again, I have two numbers, so I have to average them, but in this case, you end up with the same value, because you got 15 and 15, right? So my 5-number summary is the minimum, Q1, the median, Q3, and the max. Okay, so I already know the minimum value. It's 5. I know the median because I calculated it before. It was 22.5. I know the maximum is 85. And then I just found Q1, found that Q1 is 15. So then I just have to do the same thing for Q3. So for Q3, I'm looking at the upper half of my data. So I'm going here from 25 to 85, right? And then I found by counting that these are my two middle points of the upper half, the 40 and 45. So I have to average them just like I did for the median. So when I do that, 40 plus 45, so 40 plus 45 divided by 2, which is 42.5. So that's Q3. Okay, so 42.5. All right, so I've already drawn my box plot, and there's one thing that I want you to notice that I forgot to include that I really should have, which is I did not label my my axis here. So I didn't put any context here when I drew. So this is commute time. So commute time. Okay. So the first thing that you want to do when you're drawing a box plot is draw the box, right? So I said, okay, my Q1 is 15, which is about right here. My Q3 is 42.5, which is like about right here. And then my median was 22.5, which is about right here. So I literally just went draw a line, draw a line, draw a line, and then connect them to make the box part. Okay, and then you really shouldn't draw the whiskers until you do the outlier calculations. Okay, so here's your outlier calculations. I don't know why I did that. Outliers is not spelled with a Q. Okay, so to calculate outliers, step 1 is to find the IQR. So IQR is Q3 minus Q1, so 42.5 minus 15, which is 27.5. Okay, so that's step 1, find the IQR. Step 2 is do 1.5 times the IQR. I should write this way. Figure out what that number is. So 1.5 times 27.5 is 41.25. It does not look like a 7. Okay, and then step 3 is to find your lower cutoff, which is Q1 minus your 1.5 times IQR. So I really shouldn't write Q1. I should actually write what the actual number is. Okay, so Q1 is 15 minus 41.25. And when you do that, you get negative 26.25. So remember, this is my lower cutoff point. Okay, so I have no lower outliers because I don't have any values below negative 26.25, right? Which this is commute time. You can't have negative time. It's not possible. Okay, And then, so that's your lower cutoff, and then you have to do the same thing for upper. So you have to find your upper cutoff. Oh. Okay, by doing a similar thing, but you're going to take Q3 this time. So add Q3, 42.5, plus the 1.5 times IQR, so plus 41.25. And when you do that, you get 83.75. Okay, so that's my cutoff. So here, 83.75, which is approximately right here, is my cutoff point. So any data point above that is an outlier. And if I look at my data, I do have a data point above 83.75. Okay, so that data point is an outlier, right? The reason that we do this and we do the 1.5 multiplying by the IQR is just to give us enough room to say, like, if it's past this cutoff point, it's really, really extreme and doesn't fit with the trend of the rest of my data. So that's definitely an outlier, okay? And then one thing I want to make sure that you note is if you have an outlier, then the stem will end at the next highest point. Okay, so here my stem only on the right hand side, on the positive side, the upper side, only goes to 65, right? And the reason we do this is so that you can see the gap in the data going all the way up to the outlier if there is an outlier. Okay. Now, if there's no outlier, you just draw your stems to the minimum on the left-hand side and to the maximum on the right-hand side, right? So that is it, you all, for box plots. One other thing I do want to note for you that you can learn from box plots is that you can take a guess as to what the shape is. It's difficult, to say the least. Definitely much easier in in like a histogram or a stem and leaf plot or a dot plot. Okay, because the box plot only really shows you the 5-number summary, right, which is these 5 numbers here. Okay, but we can even see in this distribution that you have a really positive outlier on the right-hand side, and you can also see that you're fitting 25% of the data in each of these spaces, right? So there's 25% of the data between Q1 and the median, 25% of the data between the median and Q3, 25% of the data from Q3 all the way up to the max, and then 25% of the data from the minimum up to Q1. So what we're seeing here is that it's the same percentage of the data, meaning the same number of data points, are falling in vastly different areas of space, right? They're taking up more space, right? So this area, for example, and I'm going to zoom in on this a little bit more so you all can see this better. Okay, so this area right here from Q1 to the median holds the same number of data points as this part of the data going from the median to Q3, right? And so the more space it takes up, the more it is skewed in that direction. So if you have a small amount of data, that means your data is it's basically it's like short and tall, like it's thin and tall, right? And if your box takes up a wider amount of space, like width-wise, then that means you have the same number of data points that are just spread out. So it's like short and almost like long, right? So a box plot like this one is skewed to the right because you have more the upper half of the data takes up more space, like physical space on the number line and in the box plot than the lower half of the data does, right? A box plot that would be skewed to the left would look something like this, right? Okay, because you have a bunch of like tall data here, and then the data from here to here, for example, is more spread out. All right. So that is what I've got for y'all for box plots. In the next video, it's almost more of a bonus video, really. It's not something that you will ever be asked about or asked to explain, but the standard deviation formula, which you can see right here, is kind of complicated. Like, it's this really long and complicated formula. So in the next video, I'm going to kind of break down the parts of this and how, like, what each part of the standard deviation is and what it means. You do want to watch it even just for the beginning so that you can get what the interpretation of the standard deviation is. 'Cause that is a common question that is asked in multiple choice type questions and even in free response questions um, for stats, right? So I will see you all in the next video. Bye, everyone.